I don't want to put in pixels behind everything. Really. No, I don't. This is the end. Maybe not even behind the Bezier curve then. Or the plot Bezier curve. It's like assigned, so it's the same thing. It should be the same thing. Oops, no Q. Interesting question. If the root, the t value, is the same for... I don't think it is actually. Oh boy. What? Yeah, it should be if the ratio the same. The x and y axis. I mean, we have a 90-degree angle, and if I do the stuff in pixels and I want that 90-degree angle still to be the same, then of course the scaling must be the same for x and y, which I think is the case, but well, in that case it's purely, I mean, translation and scaling with a certain scale which is the same for x and y should give us the same t. So I can just use plot q here. But then the Bezier curve is in pixels, so I have to convert that one back. So this is now a point in pixels, and you have to convert that back to normal coordinates. Can I do that? Let's see, so something with plot, something with convert from pixel, yeah, this returns a point. So. Except that this thing, of course, returns a bloody point and not a pixel. But since I'm going to add support for adding a Bezier curve in pixels. I might as well add a pixel here then, doing a pixel. Okay, so this is, I think, a vector. Okay, so do we have a vector can return a point? And the question is, can you return a pixel? So then my vector can store points and pixels. I do not make a difference between those. I don't think I have another one. Huh? Yeah. Pixel. It's a different type. Convert from pixel, so it takes a pixel and returns a point. I think I'm only missing this one thing now here, that is create Bezier curve in pixel. Wait, that's called onPlot. Add a file. Okay, so just only pass our pixels, so this becomes something in pixels. The plot Bezier, wait a minute. Yeah, because yeah, okay, never mind. This constructor is kind of weird. It just constructs a base class. So I have a plot Bezier class, which is derived from the Bezier curve, and now I would just construct this because a Cairo window, a Bezier curve in pixels. The draw Bezier curve, that is in pixels, period. But the assignment of the draw object here does a conversion, which now we want to skip. So that would be this one. And now that must be then add in pixels. So the in pixels here and just calls a different function, that's all. This thing is still in pixels though. Pixels, yeah. Where is that thing defined? Should be in the same file. No, it's not. It's defined here. Okay, so I'll make a copy of that. In pixels. In pixels. In pixels. In pixels. Just the same verb. Yeah, and then of course these are also in pixels, but I'm not going to add that here. That just makes them too big. And then the conversion can be removed. This converts a normal 2 pixels, but it is already in pixels now. Hopefully this works, because I wouldn't know where to look if it doesn't. Something is failing. Find that back. Oh yeah, unknown type name pixel. Failed. Plot pixel maybe? Explicit, okay. I really can't get it to work, right? Does not want to work. Use of undeclared identifier plot Bezier curve. Oh, px, yeah, it should be in px's, obviously. It's the other way around. No magic member function for call to convert to pixels. Why? Yeah, I want this to be Cairo window point to the. Just this thing is wrong then. There's a plot point here. Was it this in plot? So I have to say that it is that. I know they have other pixels. So there's already a pixel here, but I just added that. There's a pixel here. Okay, I can just do that. Compile, damn it. Finally compile. Who makes your member function for... Is it the same error or... Guess I'll just wait. Still not. No magic member function for convert pixels. Ignoring substitution failure. Deduce non-type template argument does not have the same type as the corresponding template parameter. Yeah, it deduces, of course, the size here from the array. So that's the size type. And I was using an int because I want to use ints wherever possible. Officially, I should use maybe something like this and then the size type, but that's just gonna be size type. I think maybe even standard size type. I think that's the thing. I don't know what else to make of it. Nope, it still doesn't do it. Now the funny thing is, I often say this, if it compiles, it works. So it's really possible that you get a gazillion errors. And when it then finally compiles, you would almost expect then to get to the next level and then get all kinds of runtime error. Point cannot bind to a value of unrelated type value type, aka Cairo window pixel. It's again, no. What? Yeah, no, of course not. Okay, we have to convert it, I guess. I hate this. I mean, I don't want to actually make a copy of this. These things have the same memory layout, points and pixels, so just two doubles. So then you can only hope that the compiler is not going to do this at all and just uses the memory address that we already have. But if I want to enforce that at the code level, then I have to start to do reinterpret cast and stuff. No, can't do that. We have to trust in the compiler. So I'm doing a what is it? Copy assignments? No, yeah, I think so. The word. Constructing anyway a point from a pixel. Which is probably not even possible. Nope, can only construct it from a double. Two doubles. Poor compiler. It has to figure this out. Or, of course, I can add a constructor here to copy directly from a pixel, but nah. Well, actually, why not? If I add explicit, but it's gonna be explicit if you ever, well, yeah, okay. That it means that you really have to type in full point, I think, and then construct a point. You can't like pass a pixel to a function that takes a point. That wouldn't be explicit anymore. So it's probably safe to do that. But it's also kind of weird. I mean, now, you know, I mean, a point is not a pixel. In this case it is, but it's a special case. I don't want to pollute this code here with that. So what we do here is really weird. I have to convert back to points because the rest of my code is just assuming that you don't work in pixels, like the Bezier curve. Almost starts to feel like a design problem here. But yeah. So these things then can only be constructed from doubles. So we have to explicitly do this. Maybe I should do a reinterpret cast. I could make this an array of points as well, and then do a reinterpret cast at the moment I pass it to this. That should work. And I can just use an alias here. But okay, I think that the compiler is smart enough anyway. Plus, it's what I'm talking about. These are just a few copies. If you compare that to the rest, it's ridiculous to worry about it. Okay, convert pixel back to point. Point. Because that's the only thing we can do math in with. Not happy face. Is he $P? No, not like that. And not like that either. Okay, can't type. Replace 2, replace 3, replace 4, replace 5. Does now finally compile. Yep, it seems that it compiles. No, it doesn't. Here's an undeclared identifier Bezier curve. I guess that's my Bezier curve in pixels. I think the compilation went really slower today, and that must have been because I'm including eigen maybe in the polynomial header. I think maybe I want to get rid of that. Let identify convert from pixel. That's part of plot. Just plot. Shit hits the fan. Data, that doesn't that just return a pointer? The in data. It's a Cairo window point. Oh, okay, I forgot to add a Cairo window prefix there. I think that was it. And then we have that here as well. I think we're getting there now. Should be getting there. Definitely should get there. Yeah, I'm so late with seeing that. It's an old one, it's a 2000. It compiled. Unbelievable, but true. Now, does it work? No, does not work. Well, actually, the lines are not drawn, but it's about a Bezier curve, right? So bang, the Bezier curve is just, it's being drawn correctly. Yeah, it does work. It just does work. I think it totally works. Oh, okay. I'm amazed. But what's with my non-existing arrow suddenly? I had to have an arrow here. Maybe I'm no longer doing that actually. Yeah, I do. Create connector. I think though this goes wrong apparently. Yeah, just plot create connector. So we have to work in point, not in pixel coordinates. And this draws, it should draw from plot Q to wherever we draw to. It should have been visible. Maybe we never get here, because this is false. Yeah, of course. One is in pixels, and the other one isn't. Okay, so my min distance squared is actually now in pixels, as it should be. Distance squared. Wait a minute, I'm using plot Q here as well. I'm mixing them up. It's not type safe this way. Huh? So it really sucks. I'm definitely mixing them up. Okay, so let's have another close look at this. But this apparently worked because the Bezier curve is plotted correctly. So I'm gonna assume that we can get the roots then also, and let's see, just R maybe. R is B minus Q in pixels. Yeah, that's good. Everything is in pixels. Right, so here we got a point again. I'm getting points from it. But that's okay. It's still in pixels. I need to type point, but it is still in pixels. So this is PT in pixels. Maybe I should call it in pixels again. And then you see here now clearly that we are combining two things of different types. Well, this is in pixels and plot Q isn't. So we should Q in pixels. That's what we should do. And then this is distance in pixels squared. I'll just add it to get less confusion there. So now my min distance is in pixels. And therefore the other one must also in pixels, and that is what the real problem is. It isn't. This must also be in distance in pixels, of course, now. And then I think, well, at least then we get here, and then something should be drawn. I think that is correct. That must be in pixels. And then of course this must be Q in pixels. PX. Insert in PX. This is then in PX. Compile. Seriously. Yep, that was it. That's pretty cool. So we're back to where we were, but now I have my coordinates in pixels, which means that it is easier to see if the length here is yeah, well, less than a pixel. So here there would be less than a pixel, and this obviously all is more than a pixel. I think this is the problem. I hope that it got so slow. To remove that should be pretty easy, but this is a heavy function, right? I can just put that in a .cxx file, I think. The interface isn't even using eigen. I think, however, Polynomial, is that a template? It's not even a template. I don't have polynomial.cxx. Well, it's about time I add one then. Yeah, debug was already added in the header. Do I have a namespace here? Namespace math, okay. So yeah, let's move a few things from the header. Anything that is kind of big-ish. This might already be big actually. Okay, the roots is definitely big, right? So I want to move that to here. Polynomial. And we have another one here. Delete. What? Yeah. Print on, yeah, print on could of course be moved as well. And then most importantly now I can get rid of this, I think. And the question is, I'm using array here. Standard array, yeah, that has to be defined of course, even just for the declaration here. Complex as well, so we need array and complex. Array here, complex. Math, I don't know what math to use for, but ranges, really? Ranges, yeah. Let's see, what we'll use a vector string. Ranges, array and ostream. That's it. And the string is just debug. Seems I'm not even using CMath. Vector array, ranges, the standard complex was there. Square. No square. Almost equal. No, almost equal. Almost equal here. Nope. Okay, this is from the macros, right? So we need that one. Debug. No, that is debug.h. As is assert. Seems that I don't need that one either. This is needed for the AI, unlikely, I think. Which is not used here. Probably not linking. Yeah, it should not pick up the polynomial.cxx yet. Undefined stuff, okay. How do we pick that up? Simply resource, I think. Oh, yeah, of course. Never mind. Everything that includes a polynomial.h now must link with that. I have to manually add that, of course, to the .cmake file. So polynomial.h. That's this one, for example. That's why I didn't want to add a polynomial.cxx, I bet. I have to add that in a lot of places. A lot of places. Claim check. The cubic Bezier itself. This that I'm working on. It better compiles fast again now, before it's timid, man. You just did gradient descent? Or this one? No, this is one. Parabolic fit. Polynomial.cxx. Root test. Actually, that is not all of them. Nope. Oh, there's another one. H. Cubic. Everyone who includes cubic polynomial also needs it. probably everyone needs it. Everything that links with oh boy. Yeah, the algorithm event type, well, just everything, everyone, just everyone using gradient descent 2. I should just move it in, I don't know, I have all these polynomials, I have them in tests instead of in gradient descent for some reason, and of course I have no clue anymore of why. Probably because they are not really related to gradient descent, they're just mathematics. They're just polynomials, so I wanted to put them somewhere else. But since everything that uses gradient descent 2 is going to use polynomial, one way or another, I just have to add polynomial.cxx to everything that links with gradient descent. So like this one, for example. Gradient descent 2, that is. Gradient descent 2. Start from the top. Were these necessary? Was it analyze cubic that include? Can just jump to it maybe. Analyze cubic. No. Well, unless the header does it. Cubic polynomial, yeah, and the cubic polynomial.h includes that. So these needed as well. Still undefined stuff. Oh, this gradient descent itself. Oh yeah, yeah. This zone without the 2 also needs it, because the algorithm.cxx of that one includes it. So that would be this one. Anything that uses, yeah, well, whatever. That. Oh, there is a almost equal being used. But, yeah. Tilts almost equal. Completely different file. So I just removed it from my header. So now we get all kinds of missing almost equals. Did it get fast? I'm starting to get a feeling that it did not get really faster. Here's another one. Include a utils square. Nope, still slow. No, that sucks. Compiled. Right, okay, so time to turn this thing into some kind of interface. Yeah. Nobody knows why I'm suddenly in polynomial.cxx. Let me think. Yeah, what do we need? We need function. A function that I pass a lambda. The lambda allows me to get the values of a function. I mean a mathematical function or a parameterized function. And the result is kind of the same as what I already have, but it doesn't work. It just doesn't work. Not good enough. That's why I do this now. But maybe that is the interface that I want to go towards. So let's see if I have something that draws a function. Of course I have that. Like the Fourier test, right? Fourier test definitely draws a lot of functions. Yeah, there's a function. So the enable drawing is probably doing the drawing. L is my my function. Let's just follow the enable drawing here. Doing an enable drawing thingy. Which means I reconstructed this. Yeah, this is how we draw. Add Bezier fitter. I'm looking and looking and looking. I don't see where the plot curve is defined. Still don't see it. Okay, how about we search for it with a regular expression? It's not defined anywhere. Suspicious. It's just here in a class without a thingy at the end. Dude. None of these things have that. No thingies here in enable drawing. Sure, I'll plot us. Well, let's not do everything at the same time, but let's do plot curve. Okay, so apparently the idea is that we have some object called enable drawing here, which contains a Bezier fitter object. And that's going to store all our draw objects. And those draw objects are, of course, draw Bezier curve objects. So the Bezier fitter just has a shared pointer to draw Bezier fitter. And also a Bezier fitter here. Oh no, which one shall I look at first? Yeah, I think this is the one. A vector of Bezier curves. No, not really. But this is not what is being drawn. They probably have copies of it. This is the result. So we're going to have a bunch of Bezier curves in the end. And we also have a shared pointer pointing to a draw Bezier fitter object, which is draw Bezier filter. Where is that defined then? This is plot. Yeah, draw. That also has a vector with plot Bezier curves. So I think I want to keep this name, Bezier filter, nice name. I'm gonna use that. So I have to change the Bezier filter class so that it's going to use my new code. Well, I think it still is a multi-region and still needs a vector of plot Bezier curves. And we still have a line style. And this is a const reference called result. What was I thinking? So constructing them here, Bezier curves from a const reference. Why? Well, because I can't move them anyway. These are KO with no Bezier curves. And this thing stores plot Bezier curves. So yeah. Ish. But not really. Sounds expensive. Or am I not? Is it nonsense? Or this thing is just a matrix, isn't it? Well, just. But there's not much to move. I think it's not a vector or anything. It's not, doesn't have any heap allocated stuff in it. Talking about the Cairo in the Bezier curve. This one. It's a Bezier curve matrix. Just an array. So there's absolutely nothing that we can move. 4 vectors. So well, you can't move it, and you have to copy it anyway. So then might as well use a const reference. Oh, I went way far too back. Way too far back. To the Bezier curve itself, there's nothing to change there, right? It's going to be in pixels, though. Whether or not this is in pixels, there's nothing to do with the class itself. Don't have to change this. But this is going to be in pixels. Do I want to duplicate my Bezier filter so it can test it separately, or shall I just bang change it and break every compilation in my test until I fix it? Means I can't draw anything anymore. Aman. Not seeing chat today? What do you mean? Not seeing chat? Yeah, people don't chat, but just distracts me, so that's okay. Okay, I'm just going to change it in place, I think, but it's probably a wise thing to do a commit first, and then start doing that. I changed something here. I added the underscore. Okay. Right. have something called curve. Oh, that, yeah. It's supposed to be drawing something through a bunch of points instead of a known function. Totally doesn't work yet. Yeah, I mean, it draws curves which go through points, which is draggable. So if this one works, then it works, right? So, or the reference that we can use. So I can do, I think just make that, ignoring all the errors that we're going to get. And then I have to edit, let's say, again, just editing the Bezier vector.h for the class, which it's not finding for some reason. Okay, so I want to rename this one result in pixels. We're not going to have a depth anymore, at least I wouldn't know what that is. So, result. Well, you can get the result, get a pointer to the result vector, okay. Pixels. That's it. Depth. No depth here. And then the interface. The parametric function that must be fitted. It is already parametric. That's an awesome. Text parameter t returns a point. Domain, the minimum maximum values that will pass to func. The domain of t. Viewport. Bezier segments that fall entirely outside of this viewport will be discarded. Normally you would pass plot viewpoint here. Tolerance, the smallest deviation from the true function. Value allowed in Bezier curve output. Which isn't going to be in pixels. Let's do the tolerance in that's just in pixels. Smallest deviation from the true function value, not the true function value. Small deviation. Well, for the true function value, okay. Allowed in a Bezier curve output. -1 is passed, the default of 1 will be used. In pixels. This signature can be used, for example, when func returns a point that simply passes its argument back as the x coordinate of the point. I guess a normal function instead of a a parametric function. Or it makes a domain automatic. Yeah, so this thing uses 6 points. This is for the Chebyshev thingy. But our function is going to use, let's see, 5 points, right? Begin, end, the middle, and then in the middle of each. Actually, not 6, 7. Maybe I should do that as well. I'm not sure what is being passed to this actually, but I think we need more than just points here now. I need a direction vector for these things as well. Oh, that means that the standard function must be changed. This just returns a point now. I need something more complex. But okay. On the large scale, it's kind of not that different. Except that I changed the definition of tolerance. We'll never know, I guess. Well, anyone who creates a Bezier vector or calls solve, I guess I'll just have to search for that. Grab source, solve. Do a lot. But this is the Bezier vector itself. Here's a solve. Solve. So this is one per file. I'm just going to search for the solve inside the file itself. That's something else. This isn't. Green descent. That's again, I don't know, an eigensolve. this call to solve is not passing a tolerance. It's just passing the viewport as last argument, so I can just leave that alone. Same thing here. I don't really expect tolerance to be passed at all ever, to be honest. Viewport is the last one in all cases. And back to the top. Viewport, viewport, viewport. Looks like the same file. Or am I wrong? Next. Okay. And then construction of a Bezier fitter. Jesus, find that bag. No, it's not even that much. So probably not in the Bezier fitter definition itself, nor is it a header. No. You can even see here that it also ends on the viewport. This is a default constructor. Yep. Also viewport. So no, nobody passes a tolerance. That's good. That's why I changed this. And then of course I have to change the .cxx file. This is going to change drastically, I think. Not even sure what this is doing. Yeah, well, if the default is 1, I might as well make the default 1 instead of -1. It's no longer a function of the viewport. We're going to do stuff in pixels. So the tolerance here is being passed to solve, and it's just whatever equals -1. Let's change this in 1. So decimals blah, 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 in pixels, so that's no longer true. There's no -1 here anymore. Huh? No. Okay, so then we have this taken care of. Domain minimum. So that domain must be in pixels then, I think. Oh no, wait a minute. The domain is the parameterization domain. Maybe I do want to keep track of the depth though. You never know. Let's add depth back. So it's a depth of 0, now equals solve, which is the more sophisticated solve. The private solve. Passing func, which is no longer good enough. And the viewports and the tolerance and the T0 and T6 values and a vector for the value at T0 and a vector for halfway and the end. Yep. So this would be P0, P1, P gamma, but we also need a direction at this point. Okay, so adding the depth back, just an int. Okay. I think we should start with changing the function. Started to doubt now. I can now draw. No, wait a minute. No. Yeah, that's why. I'm using the direction in the begin and end point because if I can fit a Bezier curve through 4 points, but then you have nothing to say about the direction it goes into at the begin and end. And we're going to connect a lot of Bezier curves. So you would just kink, you would just get kinks every time you switch to a different Bezier curve. It would just so the Bezier curve would end in a point very nicely there, and then go in that direction. So we have to force the derivative, as it were, as well in at every point, begin and end point of every Bezier curve. And yeah, the only sensible way, I think, is to not to guess it, but to just ask the underlying real function what the derivative is in that point. More work for the people who want to draw something, though. If you have just a function, you can't draw it anymore. You really have to provide a derivative as well, then. That might be a problem, maybe, for certain functions, like functions. If you want to draw a function you just don't have a derivative of. Maybe I should not throw away this solve. You can always fall back to this one if the other one, if the one that demands that you pass a derivative as well can't be used. But then I need my old tolerance back. or not, of course, right? I mean, I can rewrite the whole thing that I have now such that the result is in pixels. Even though we use the Chebyshev stuff. Actually makes kind of sense to do that first. You see that everything works, and I know that under the hood it's already in pixels. So it didn't change much, did I? So far. So I'm having I had a result. Place back, clear. Yeah, that's it. So this just must become stuff in pixels. These are just points. The only really important thing here is that the tolerance now has a different meaning. Or actually it doesn't. If the thing is in pixels, this still holds, I think. It's the X residue. So if X is in pixels, then you can just compare it just the same way. So this already works. The only thing I have to do is pass in a function that works with pixels instead of the normal values. But we don't. We pass a function that is using normal coordinates, not pixels. That then is the only thing that needs to be changed. So if we compile this, I think it should compile. Oh, almost. Going to rename this to result in pixels. Circle Bezier, really? P0. Yeah, okay. Just draws the begin point of the Bezier curve. So this is a point, and it is a point, right? P of the Bezier curve. Yeah, it's just a point, but it is in pixels now, and I want to convert it to yeah. So I have to do plot dot convert from pixel. I don't think that convert from pixel accepts. It only accepts pixels as it should. So instead of using P, I think I can just use B, which is then a vector, and a vector can be converted to a pixel. Can even do just B. The default of B is 0. Yeah. Maybe introduce a new member that just returns a pixel, because we're going to do a lot of pixels, pixel Bezier curves now. Might as well add a special function for it. I kind of don't like to pass 0 to B, but yeah, it's inlined. This is inline function. Huh? So if you don't pass anything, then T is 0, and the compiler shouldn't be so stupid to do multiplications with 0 constants. So the result will just that it returns this. If you don't pass anything. And then the call to pixel is yeah, also doing nothing. So a memory map of what we have. Now, lots of work for the optimizer, I think, but in the end it's just doing literally nothing. What am I missing here? The trick of renaming stuff. The compiler automatically tells you where you have to pay attention. This call creates default constructed plot Bezier curve objects from result vector. From the result in px vector of okay, goes in Bezier curves. Goes in px, I guess. Yeah. These things are also in pixels, but I don't feel forced to add it. Why? I would add in pixels here if only this thing had in pixels, but it doesn't because it's a member function, which I never renamed. It completely depends. I can put in the Bezier vector what I want. Although I'm going to put pixels in it, but yeah. bit dubious here. Maybe we should rename this function as well. I am working on Bezier filter. Yeah, the draw Bezier filter is going to be changed as well, of course. Yeah, I think I should indeed add in pixels behind here. And then of course we can rename this. And now this is in pixels, and therefore this is in pixels. Add Bezier curve in, damn it, pixels. There we are. This function has been fixed. And we got here because the result, yeah. So is there another result? Nope. Sure. Must be broken. I don't like it when it's guaranteed broken, but it compiles. If it compiles, it should work. It's not going to work this. Nope. You have nothing. And I think the reason is that for fitter. This thing changed such that now W is actually in pixels. Oh, I'm interpreted. Yeah, okay. I don't want to change this. I really want to use W and Quartic and blah 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 blah. Past viewport. Exactly like it is now. But internally, it's got to convert that to pixels. That's a problem. Okay, so the filter 2 is being moved into this function here, which is then the Bezier filter there, which is again moved into the Bezier filter here. Absolutely no idea, no. Say that is this one. Pretty boring. It would not set the draw object. Yeah, we're not calling the constructor, I think, are we? Are we? Well, we would be if we pass a function and a viewport. Enter our domain to the Bezier filter constructor, but we're not. We just pass the Bezier filter as is here. But it was constructed then already. So maybe the thing was already solved before we even got here. fitter 2. Yep. So this is the one that is doing it. Constructing a Bezier fitter from a function and a viewport. This one. That's going to call this function, which calls solve. In the end, this is always solve. So we end up in this solve here, rather probably in this solve. We just pass the function on again to this solve. And it's called func here, and now the func has changed, well, should change the meaning rather, because my func is going to return a point, and I have to convert a point to pixels, because these things now must be in pixels, I think. Well, yeah, everything must be in, everything must be in pixels, except func is not in pixels. So it's just a matter of changing that, I think. Func is no longer called after that. Oh, it is here. No, it's just being passed. So just these lines here, they must be converted, which I can only do if we pass also the plot. I don't have my plot objects. How would that normally work then? Conversion must happen anyway at some point. Oh right, yeah, so that happens here. But now it's being constructed here without having the plot. I think it just means that I can't call solve. I can only call solve from this function. So let's solve that by demanding we get a plot being passed. To this solve. Because really we can't demand that that the user passes something that passes a function that is in pixels. That would be ridiculous. Actually, an hour or so ago, I realized that the tolerance only works after the conversion to pixels if it's a scaling that uses the same scale for x and y axis. So maybe I've been just too lazy to convert the whole thing to pixels, and I'm suddenly getting second thoughts. If you don't do that, The only reason I did that is because I was like, yeah, well, at least then I understand what tolerance means. I think it was a mistake. Which literally means that every change that I made today with the in pixels is wrong. I think here's where I stop. Because, oh no. I have to sleep on this. Do I want to change that back or not? I'm definitely not going to do that right now. And if I do it, I must be sure. So I have to think about this for a long time. Let's lose a game of chess. Light chess. Yeah, this was a theory, or maybe is still. It's kind of boring to do the same thing over and over. What do I play this bishop? Chase my knight back, place that one, and I can't play that because he takes here. Threatens a fork, I can't go here. That's bad. Okay, I'll just do this. Do you know? Otherwise he could have taken here if my bishop was here instead of that one. So in the end I want to go back. And if he takes my knight, we play this one back. And this bishop is doing nothing. I mean, it's all about this square with a white square. This bishop is not helping with the white square, so you want to exchange the bishop against a knight. So normally you play the knight here, there, bishop here, and he takes. Then there is this trick that you can stop the bishop from going here by playing this pawn, because you can't take it. If he takes it, you put the queen here, and then you win. You win a piece. Poisoned pawn. But now this knight is still on the edge, so I was not really sure if this is the right order, or that we first should have played it. I mean, if we would have played this and he did that, so yeah, I don't want him to take here. I remember that vaguely. So we can go back now. And he still can't take here. So in the end, it's... Oh no. What is he going to do with that bishop? Now he's threatening to take though, because if then I attack it, I can't take there anymore. Do I want to sacrifice this pawn? Alternative is just play this pawn, I guess, and he can't take it. Kind of weird. Can hardly believe that this is the right thing to do. Aims again on that square. Totally sucks. Okay, pushes, I take, he takes, I take, he takes. And then I just have to bring that into the game. 1, 2, 3, 1, 2, 3. Can also not take. But then this bishop becomes too bad. Let's not do that. A minute, what about this pawn? If we take back like that, well, he still has to move that rook. Can't take my pawn directly. The rook comes here. Oh, he doesn't do that. Yeah, maybe I did not do that very correctly. Oh boy. Oh boy. Yeah, no. Lost. That is a lost game, basically. But yeah, I promised you I would lose. I always lose. Don't see it. Can I just take it? Oh, that's the trick. That was the trick. Problem. And running out of time as well. Maybe I have something now. That is depends. It's just going to move the queen, of course. Attacking this thing. kind of threatening to go here, am I not? Nah. It's not really a threat, I guess. What about the bishop itself? Nah, also not. I'm stupid. I can just take the rook. Shit. Okay, I give up. Oh, he doesn't see it. Oh my god, he doesn't see it. I gave away a full rook. And now I'm up 5 points. I'm a lucky bastard. Resigns too soon. Poof. Horrible game. Probably have to give a back a pawn, so why not make a double pawn here? And then try to develop giving back my pawn. Is this an option? I think so. Oh, holy moly. Yeah, threatens mate and a triple attack on this point, which is very, very, very nasty. But he's gonna have to take with the bishop, otherwise he just do this. So you would take with the knight. And if he takes with the knight, I have to move my queen. This is dead. This is pretty deadly, this. Unbelievable. Yeah, anyway, the only way to stop mate is this. Just play it. Yeah, and that's check. So if I take it, he just wins equality or something. Don't want to take it, it's just way too nice here. Go to the side, then the queen comes here, maybe threatening something. I just take. And then I'm still going mate. No. Queen comes here, so I go here, queen here, I take here, and the queen goes there, mate. Yeah, that doesn't work. I have to take. You get the same thing really. You just take with the queen and go here, and then the queen goes back. Oh, but then the bishop is gone, so then I can take the knight. Yeah, queen takes rook, absolutely. What else? And now I'm no longer up material. Dang. Guess going back is the best move. Pins the pawn. No, it does not do that. Yeah, I'm down material. Down material. Does not want to exchange. Maybe it also does not want to exchange there. I just go for development. Show me. Okay, does want to do that, and now I lose my bishop. Okay, I resign. That's just horrible. Oh shit. I always go to bed depressed for some reason. Maybe I should really stop playing chess at the end of the day. Okay, yeah, the end of the stream. I'm going to watch a movie, I think.